Hey, so in today's video, I'm going to be teaching you how to build a mobile app that teaches languages through photography using GPT-4o. So how the app is going to work is you snap a picture of something, say in AirPods case, select your language, and in this case, Chinese, and GPT-4o will basically translate the object in the image to your target language and display it for you, along with maybe some romanization pronunciation. So as you can see, this can work for any object, as well as pretty much any language. So here's a demo video of how it works. I'm going to snap a picture of this cat toy in the French language, and it will go ahead and translate it for me. So let's talk about the tech stack. The tech stack is actually quite simple. We're going to be using Expo and React Native as our mobile client, along with the Expo camera package to actually take use of the phone's camera. We're going to be using NextJS as our backend to serve our API endpoints. We're going to be using supabase as our database and our image storage. And finally, we're going to be using GPT-4o as our image analysis AI. So here is roughly how the whole flow is going to go. On the client side, we're going to start by having the user take a picture. And when they take this picture, they should also have a language that's already been selected. Let's say in this case, the language is Hindi. So they take a picture or something, the language is Hindi. First, we upload the picture to supabase. So this is uploading the image to supabase in exchange for a URL that we can then access. So this will give us an image URL. Next, we're going to send that image URL along with the language that was selected in our prompt to our image model, GPT-4o. And GPT-4o is going to return a string response. And this string response might look something like this in this example. So, English tag, paper cup, and English tag, and then the translation. And then we're going to parse out this data and then render it back on our client like so. So yeah, let's get started. We're going to go over 4 major steps, which is first, we're going to set up the project. Then we're going to set up the front end and then the back end. And then we're going to wire it all together. So for the setup of the project, I like to use this starter repo called Create T3 Turbo. If you aren't familiar with the T3 stack, the T3 stack is the most type-safe way to build a full-stack Next.js app. And then the Create T3 Turbo repo basically builds on top of that to create an entire mono repo that contains a Expo app, a Next.js app, a database, an ORM, and so forth. So it's much more robust. And yeah, because it comes already with the Expo and Next.js components set up, and it already includes supabase, I prefer to use this repo since it has all that stuff set up for us. So you're going to go ahead and set up this repo, run through the installation instructions, and get the Expo app up and running on your computer. So you're also going to want to make sure you install the Expo camera package. So to install it, make sure you follow the instructions by not only running the npx expo install command, but also ensuring that you do the proper configuration for iOS or Android, just depending on what platform you're choosing to build on. And then on the Next.js side, all you're going to want to do is really install the OpenAI package. And this is what we're going to use to actually call the OpenAI GPT-4 model. So I'm in the main component of our Expo app, and I just wanted to walk through the primary function of the app, which is basically the taking picture and uploading to Supabase and getting the AI response. So let's go through that component really quick. So in this case, we're going to be diving into the take picture function, which is called by our camera view when the shutter button is actually pressed. So when take picture is taken, first we call the actual take picture photo. And some things to point out here is that we want the quality to be as low as possible, and we want skip processing to be true. So both of these things will get this function to return a result that is faster and smaller in size. And the reason we want that is because latency really matters here, and the smaller we can get the image, the faster the AI will respond. We take this another step further by actually also resizing the image. So by default, the camera will take a photo that is the size of your screen. But if you resize it, this will just be far faster to process for the AI. So after we resize it, we're going to go ahead and set the base64 string of the image. And once the base64 string is set and the set loading state variable is true, we're going to go ahead and now upload and generate with our AI function. So let's go through that component really quick. So I have this function, upload and generate, inside a use effect. So this use effect will run when the base64 string is set and set loading is true. So first we upload the base64 string to supabase to get a public URL, image URL for the image. So the reason why we like this is because it's faster to send a image URL to OpenAI rather than sending the whole base64 string. Because this is just a very, very large string. So once we get the public URL, and we also have the language that is currently selected, so let's pretend the default language is, say, Japanese, we can go ahead and send both of these things, the image URL and the language, to our backend. And in this case, I'm using TRPC. You can use any backend you like, but I'm going to go ahead and walk through what's happening on the backend when this function is being called. Cool. So here I am in the TRPC backend. So this create function is what is being called on the front end. And as you can see, I am getting the image URL and language as the input. And then I am calling OpenAI with this translate image function that I defined. So let's go into the translate image function really quick. So translate image, this is where the magic is happening, and this is where I'm actually communicating with OpenAI. So as you can see, I'm just instantiating the OpenAI client. I'm calling the GPT-4o model, and then I'm also passing in the image URL as well as the prompt. So I want to talk about the prompt really quick. So this is the full prompt that we're sending to GPT-4o. I just want to go over the key components really quick and kind of talk through my thinking when I was writing this prompt. So first things first, just giving it any LLM just a high-level context of what exactly it's doing is extremely helpful. So basically, it's supposed to be a visual translator. Please study the image carefully and identify the main object or location. And then onto the actual main task, which is write the English name for the main object or location in the English inside these English-looking tags. So the reason why I do it this way is because it will then make it easy to then parse the English, the translation, and the romanization strings out of the AI response, and then we can render those in our UI. So now translate the English name you wrote into a template string language equivalent. So this is the JavaScript's way of inserting variables. And in this case, our variable is the language that was selected on the front end by the user. So let's say Japanese. So you wrote into a Japanese equivalent. Remember, the translation should be beginner friendly, so keep it as simple as common as possible. This prevents really, really long descriptions from coming out. This just centers the app to focus more on just simple objects, simple translations, which is I think what we want. Then write your language, in this case Japanese, so write your Japanese translation inside these translation tags. If Japanese has a romanization system, which in this case it does, write the romanized equivalent inside romanization tags. Otherwise, omit the romanization. So just in case you're not familiar, romanization is basically like the English way to pronounce certain words from certain languages. So lots of languages have these, like Chinese has the pinging system, Japanese has their own romaji system. Not all languages have this, so that's why I made it kind of optional. So after we get our response back from the AI, we go ahead and write this quick function to extract the data between those tags that we defined in our prompts. So for example, English, to get the English data, we extract from the English tags with regex, and so forth for the translation and romanization. And then we just return this all, and then our backend just returns the exact same data. So it returns the English translation and romanization to the front end. So back in our front end, we've just received the response from the back end, and we got the English, the translation, and the romaji, or the romanization. We're going to go ahead and set that to our state, and then set state to true, set the postcard state to true, so that that postcard with all of our data, as well as the photo. And that's basically it. There's many ways you can extend this, but that is the crux of the product.